everyone. Today we are going to be talking about our unit circle again. Today we're going to be specifically talking about these things called radians. Okay, now radians, just to start here, just a quick explanation of them. They're another way to measure angle measures. Okay, so just like we use degrees, we can also measure those same angles in what we call radians. I want you to think of this as the difference of like measuring something in inches to centimeters. Like we're still measuring the same thing, it's just a completely different unit, but ideally it's the same idea. Okay, now radians in degrees do vary quite a bit in the way that we measure them. In degrees, we think of the degrees kind of on a protractor that we can separate things all the way around as 360, all of that sort of stuff. Radians are a little bit different. Radians, if you think of this word, you might think of the root word, which is radius. Okay, the radius is really what determines how long or how big a radian is. Okay, specifically what we define a radian as is 1 radian is the distance around the outside of the circle that is the same as 1 radius. Okay, so let me explain that a little bit more. Think of if I had just a piece of string that went from the center of my circle to the outside, so the length of the radius. If I then took that string and I attached it and I started to bring it around the outside of the circle, okay, it's going to end up right up here somewhere. Okay, that distance is 1 radian. Okay, so 1 radian is there, 2 radians is going to be over here, 3 radians is going to end up in here somewhere, 4 will be down 6, and we're going to be a little bit past 6. And I know that that might not be super obvious right now, but we'll get to that. Okay, so let's think about how many times can the radius fit all the way around the circle. Well, all the way around the circle is this thing we call circumference, and circumference is equal to 2 pi times the radius. Well, in this case, this is the unit circle. We know the radius. The radius is 1. So 2 pi is the distance around the circle. The radius is 1, which means the radius can fit around the circle 2 pi times. Okay, now that's a little bit weird, but all the way around the circle is going to be what we refer to as 2 pi. And just like with degrees, you could also call this 0 pi, just like 0 degrees and 360 degrees. That kind of has 2 names because we always start at this point as well. So 2 pi is all the way around. Now, the way that we're going to fill in the rest of the radians is to think about this circle as like a pie, and we're going to start to cut it into different pieces and see that if the whole thing is 2 pi, then we can break it down into smaller parts of pi and work with that. The easiest one is probably to cut it in half. So if I cut the circle in half, I'm over here on this side, okay, and half of 2 pi, well, that's going to be just 1 pi, or simply pi. Okay, well now I have pi is like halfway around the circle, so 3.14 times around the circle. Okay, that's where I got the 3 and then a little bit more than 6 over here. But we can also start to break down it more. So if I do half of the half circle, which is up here, that's my quarter circle, well that's half of pi, or pi divided by 2. And I can use that same fact to go down to the bottom. Okay, I can go a pi over 2 past pi, which is pi plus a half, or 1.5 pi, but we're going to keep all of these exact as fractions, so we're going to call this 3 over 2 pi. So I have 3 over 2 pi at the bottom, I have pi over 2 at the top. Let me zoom out just a little bit more so we can get these all in here, and we have those 4 kind of main points labeled with our pi's now. Now from here we need to start to break this down a little bit more. So I'm going to take my quarter and I'm going to split it again. So I'm really talking about the 1/8 of a circle, which is this middle point, which we did call 45 degrees. Well, now I'm taking pi over 2 and I'm splitting it in half. Well, half of half is a quarter. So this is going to be pi over 4. Now, that's as far as I'm going to split for now. What I want to do is I now want to work my way around the circle, counting by these pi's over 4s. So pi over 4, which we're going to now say is the same as 45 degrees, shows up wherever I would normally have those 45 degree angles. So if I start at 45 degrees, if I go another 45 degrees, I now have 2 of these pi over 4s, or that's the same thing as 2 pi over 4. And I'm putting this one inside the circle because if I look, 2 pi over 4 reduces. 2 over 4 is the same thing as 1 over 2, or pi over 2. So this one here is actually a duplicate of what I already have. I don't need this one. We like our reduced answers, which is what I have on the outside there. So I go to the next one. If this was 2 pi over 4, then the next one's going to be 3 pi over 4. 3 pi over 4. Then I move to the next one, which would be 4 pi over 4. Well, 4 over 4 is the same thing as 1, so that's the same as my 1 pi. Okay, so again, this one cancels. I don't really need that one. Okay, but I still put it because that was my 4. If I don't put that one, I'm going to try and put 4 here. So I put 4 there. Then I would jump to 5. So over here, this is 5 pi over 4. Next jump is going to be 6 pi over 4, which again reduces. 6 over 4 is the same as 3 over 2, so the same as I have there. I can get rid of that one. And then my last, sorry, not really my last jump, but one of my last ones here is going to be 7 pi over 4. And then the very last one would be back to 8 pi over 4, but 8 over 4 is the same as 2. So I'm not going to write that one. That's my 2 pi. Okay, so basically going around the circle with these pi's over 4s, we can end up getting most of the points that we have. And I say most because we missed some. Okay, specifically these ones kind of in between our mains and that middle one. Okay, so now we need to figure out how can I get those. Well, this is where it starts to get a little bit trickier. We know that these angles here, based in degrees, are 30 and 60. Okay, and so what I'm going to do is I'm going to actually take this pi and see if I can break it down into a way that hits both of these at the same time. Well, if I include this one and this one, I'm going by 30 degrees, so I'd have to count the 90 as well. I'd have to count the next one, this one, and then finally I get to 1. Well, if you count how many jumps I made there, I made 6. So I have 1, 2, 3, 4, 5, 6 jumps to make up pi, okay, or half the circle. So what I'm going to do is I'm going to say over here that this is the same thing as taking pi and dividing it by 6. And that's my 30-degree jumps that I'm going to make. So starting with pi over 6, if I make one more 30-degree jump, I end up at 2 pi over 6. Well, 2 pi over 6 reduces. 2 over 6 is the same as 1 over 3. So I'm going to call this pi over 3. I'm sorry, my radian piece got in the way there. Then I'm going to go to the next one. Well, if this is 2, the next one is 3. So this is 3 pi over 6. Well, 3 over 6 is the same as 1/2. That's the same as what I already have. So again, just another version. I don't need it. Okay. Then I go to the next one. Well, from 3, I would jump to 4. So this is going to be 4 pi over 6. Well, 4 over 6 reduces. That's the same as 2/3. So this is 2 pi over 3. Okay, and this one cancels out. Next one, I would go to from 4 to 5. That one does not reduce, so we'll put that one on the outside. Next is going to go to 6. So 6 pi over 6, which cancels. It's just 1. 6 over 6 is 1. Then I go to 7. That one doesn't reduce. We'll put it on the outside. 7 pi over 6. Down on the bottom here, I would go to 8 pi over 6. Put that on the inside because I can reduce it. 8 over 6 is the same as 4 over 3. So 4 pi over 3. Next one is going to be 9 pi over 6, which does reduce to the 3 over 2. So I can get rid of that. Next one is going to be 10 pi over 6, which we'll put on the inside because that can reduce to 5 pi over 3, which cancels there. And finally, I would go to 11 pi over 6, and the last jump would be 12 pi, which again is 2. So, this is our radians. Okay, now radians again get you to the same places we've been talking about in the unit circle. Okay, we're not talking about anything new in terms of where the unit circle is set up. The only thing that's changing is how we're getting to each of these points. Okay, before we go on to how we might use these, let's talk about some patterns here. The biggest thing I would focus on as far as the patterns are how I actually generated this. So really what I'm doing is I'm counting by 45 degrees, which was the same as pi over 4. And I'm counting by 30 degrees, which is the same as pi over 6. If you count around the circle with those two things, you'll fill in all of them, including the 4 main ones that we actually started with, as long as you reduce everything. So you gotta make sure you're reducing. We don't want any fractions that could be reduced. Okay. The other thing I would point out, I'm not going to draw this in, but I do want to show you here. If I start with pi over 6, if I go straight across, I get a denominator of 6. If I go straight down, I get a denominator of 6, and straight across again, I get a denominator of 6. Same thing with the over 4s, 4, 4, and 4, and over 3, 3, 3, and 3. It actually even works with the 2 and the 2, straight up and down. Okay, so you can start to follow some of those denominators. The numerators are a little bit trickier. First quadrant are all 1s. The second quadrant, what I think of is these are 1 away from making the whole. So I'm 1/3 away from making it a whole, so it's 2/3, 3/4, and 1/4 away. I'm 1/6 away, it's 5 over 6. And then the third quadrant is 1 above making it a whole, because that's what I am here. So I have 7 over 6, 5 over 4, and 4 over 3. Okay, and 3 over 2 for that matter. Okay, the next one here, this one's probably the trickiest one. I would say you're 1 away from making 2, but that's kind of a hard pattern to know. So you might just think of the 5, 7, 11, and you can kind of work with that. With radians, again, there are patterns there that you can try and memorize. I tend to not memorize the patterns. I think more of these pieces and just work my way around the circle. Okay, so that's radians, that's where they come from. Let's quickly talk about how we might do some radians. Okay, now I'm going to actually switch to a different unit circle here. What I've done with this unit circle, and this is one of the files that you have available to you in Google Classroom, is I've now put all of the information together. So this includes our radians, it includes our coordinates, and it includes our degrees. Okay, what you can see is that at every point I have a degree measure, a radian measure, which are my things in blue here, and then my coordinates. What I want you to think of with radians is it's the exact same thing as degrees. Okay, the only thing that's going to change is it's going to say I want a radian measure. Okay, or it's going to give you something with a pi in it. Okay, and so what it's going to say, let me take the back of mine here just to give you some examples, is I might say what is cosine of pi over 4? Instead of saying cosine of 45. So what I do is I go find pi over 4. Well, that's right here. Cosine is your x coordinate, so it's the square root of 2 over 2. Okay, so these are going to work the exact same way. Okay, I might ask you sine of 5 pi over 3. Okay, well 5 pi over 3, that's down here at the bottom. Okay, sine is your y coordinate, so this is a negative square root of 3 over 2. Okay, and I'm not going to go through a ton of examples with these because you can start to figure out that it's really the same thing. Okay, the only thing we've changed is how we get to those points. Instead of looking for the degree, I look for the radian. Okay, the only other one I do want to mention is something like cosine of theta is equal to, let's actually do 1/2. Now this is actually the same problem we've done before, but the only difference is I would ask you for 2 angles between, and this between part is the new part. It's going to be between theta and 2 pi. So I'm not going to see 360 anymore because I'm not talking about degrees, I'm talking about radians. So the fact that I see 2 pi here means that my answer needs to be given in radians. So now I'm looking for cosine in 1/2. Well, cosine is my x coordinate, so this is asking me where do I have a 1/2 as my x coordinate. Okay, if you remember back to our degrees video, this is the same example I used. It's right here at the top at pi over 3 or 60 degrees. I have my 1/2, and then right below it as well at 300 or 5 pi over 3. So because I'm using radians, I need to give my radians as my answer. So I would give it as pi over 3. That's my 1 up here at the top. My 1 down at the bottom is 5 pi over 3. Okay, so those are my 2 angle measures. That would give me that type of answer. Okay, and then the other type of problem you could have is just the positive, negative, 0, just like we had for degrees as well. Again, just try and figure out where those radians might sit in between all of these, and then figure out what your coordinates might be from there. Okay, that's going to wrap it up. Excuse me, for our radian video. There is a little bit more that we can do with the unit circle and kind of extending it beyond the one time around the circle, but we'll talk about those more next time.